So in this video I wanted to talk about the greenhouse effect, which is a pretty important effect that affects the Earth's atmosphere. So before talking about the greenhouse effect, let's first talk about what's a greenhouse period. All right, so if you've never seen one, this is what a greenhouse looks like. All right, so it's the greenhouse effect is named after this type of thing because the same thing that this structure does, the Earth's atmosphere does to the Earth. All right. So even though this thing has some things which are painted green, that's not the reason that this is called a greenhouse. All right. So a greenhouse is essentially just a glass house. All right. If you were to say what color is a greenhouse, it really doesn't have a color because glass is just whatever color is on the other side of the glass. All right. So the way this works is imagine you have this structure and you close all these doors. These are some doors right here which are made of glass. These are some panels that are open. But if we closed all the doors and we let the sun shine through this, all right, what's going to happen is that the energy from the sunlight is going to come down and some of the things inside the greenhouse are going to absorb that heat. All right. And when that heat, those objects are then going to try to release some of that heat, but that heat's going to get trapped inside because there's nowhere for it to escape. All right. So what ends up happening is more heat ends up getting absorbed than released, and so the temperature warms up inside the greenhouse. All right. What makes the greenhouse useful is picture this being, a time of the year like winter or spring or fall where it's not warm enough outside the greenhouse to grow plants. All right. Well, it's very possible that the temperature is warm enough inside the greenhouse to grow plants. All right. So it allows you to grow things during times of the year that it's not normally warm enough. All right. So the reason it's called a greenhouse is that since it's used for growing plants, if you were to go inside, you'd see a lot of green things. All right. That's why they call it a greenhouse. All right. So so the greenhouse effect is named after this structure. All right. So what is the greenhouse effect? All right. It's the capacity of certain gases in the atmosphere to trap heat emitted from the Earth's surface, thereby insulating and warming the planet. All right. So let me move this up. All right. So if you know anything about the greenhouse, you've probably heard about some pretty bad things. And there are some bad things having to do with the greenhouse, but one thing about the greenhouse is that we kind of need it. All right. If we didn't have some amount of the greenhouse effect on Earth caused by the Earth's atmosphere, it would be way too cold on the Earth to support any type of life. All right. So in fact, it would be about, on average, it would be about 59 degrees Fahrenheit cooler than what it is right now. All right, so just to put that in perspective, if it was 59 degrees Fahrenheit cooler, it would be way below freezing all of winter, and it would be barely above freezing in the middle of the summer. All right, so that's going to be way too cold for normal life. So just a little bit about light, first of all. Light is part of what we call the electromagnetic spectrum. All right, so there's actually a whole lot of types of it, one way you can think about it is invisible light that the sun creates. All right, it creates microwaves, infrared waves, ultraviolet waves, X-rays, gamma rays. But one thing that our atmosphere does is it actually blocks most of these other types of waves, and that's a good thing because especially the ultraviolet, X-rays, and gamma rays would be pretty damaging to us. So most of the light that reaches the Earth actually is what we call the visible light. All right, and the reason that it's called visible light is that's the type of light that our eyes can see. So when visible light hits the Earth's atmosphere, some of that light is actually reflected back into space. All right, so one property of our atmosphere, and you can kind of see the outline of our atmosphere here, is in some ways it acts a little bit like a mirror. Where some of that light hits it and just bounces straight back out into space. All right, and so that light would have no effect on warming up the Earth, but some of it of the light does penetrate the atmosphere, and ends up being absorbed by materials on the Earth's surface. So if you wanted to know, why does the sun make the air warmer? All right, one thing that's important to remember is that sunlight doesn't really warm the air directly. All right, sunlight, the way sunlight makes the air warmer is actually the objects on the surface of the Earth, the ground, that absorbs the sunlight, and that ground warms up, and it's actually those warm things on the ground that warm the air that's above the ground. All right, so remember, it's not that the sunlight directly warms the air, it's that the sunlight, when it is absorbed by the ground, that ends up warming up the air. So when that solar radiation hits the surface, there's two things that can occur. First thing that can occur is some of that light could just bounce off the surface and go straight back up into outer space. All right, so those would be lighter colored materials. Things like if you've got an area that's covered with a lot of snow and ice, all right, a lot of that radiation is just going to hit that and bounce straight back off. So the other thing that can happen is that some of that light energy could, instead of it being reflected, it could be actually absorbed by the Earth's surface. And when that happens, it's going to get transformed into heat energy. All right. And a classic example of that is shown in this picture right here. This is like some really dark colored pavement right here. And if you've ever stepped barefoot on dark asphalt in the summer, you'll notice it gets pretty hot. All right. So when that sunlight hits this dark colored material, it ends up getting really warm. All right. And what this picture shows here is that actually it gets warm enough that you could, if you put an egg on top of it, it would fry the egg. So if you have that really hot pavement on a summer day, well, the question is, why doesn't that pavement stay hot permanently? Why does it eventually cool down? All right, and it has to do with something, a property that materials have, and that is that they can re-radiate heat energy. All right, and so when an object, and all objects do this, they're constantly radiating energy, and objects will radiate away their heat energy in the form of what's called infrared light, all right, which is actually an invisible form of light, and it's in this part of the spectrum right here, all right. And so when objects on the Earth's surface get warm, they're going to have a tendency to want to radiate that heat energy back out into outer space in the form of infrared energy. So essentially, again, we have some of the sun's energy being absorbed by the Earth, all right, but we know that some of that heat ends up getting re-radiated back out into outer space in the form of infrared radiation. So the question is, why doesn't it get just incredibly cold whenever the sun goes down? All right, because, again, like once the sun is down, we don't have anything to warm up the Earth, and we know that things are going to be losing energy because they're going to be radiating that energy. Well, the answer is our atmosphere. All right, and our atmosphere is made up of a bunch of gases, and one property of those gases is that they can absorb some of that infrared radiation that's being radiated by these warm objects down here. All right, and so things like water vapor in the air, and as you can see here, carbon dioxide, methane. The number one thing that traps the heat actually is water vapor, and so the presence of those things in the atmosphere hold in a lot of that heat that would ordinarily just go back out into outer space. All right, so does some of that infrared energy eventually get radiated back into outer space? Absolutely, a lot of it does. All right, but there's enough of these gases to trap enough of the heat to keep things relatively warm. All right, and so if you've one thing you probably realize is that even on a summer night, the sun could have been down for 8 hours, but it's still really warm outside. All right, the only reason that it's that warm is that we have this atmosphere. If we didn't have the Earth's atmosphere, as soon as the sun down, it would get really, really cold because there would be nothing to trap any of that heat. All right, so what are some of these greenhouse gases? All right, here's a list of the major greenhouse gases. And most of these greenhouse gases are actually naturally occurring materials. The only thing on this list that is arguably not naturally occurring would be the CFCs, the chlorinated fluorocarbons. All right, carbon dioxide, all animals will breathe that out. Methane is generated, it's produced in hydrothermal sea vents. All right, also whenever a volcano erupts, it's going to spit out a lot of that. Water vapor is present. That's why we have clouds. All right, and all of these things act to trap a lot of that heat that gets radiated from the surface of the Earth. But when people talk about the greenhouse effect and how it's affecting the Earth's climate, the one that's on this list that is the most important is going to be carbon dioxide. All right, and why is carbon dioxide really important? It's because the amount of carbon dioxide in the Earth's atmosphere is increasing as time is going on, and it's thought that the reason for that is human activity. All right, every time you drive a car and you burn gasoline, all right, one of the byproducts is carbon dioxide. All right, and so we are putting a lot more carbon dioxide into the atmosphere than would normally be put into the atmosphere by natural processes.